Welcome to the engineering technology class for February the 3rd. As I mentioned right before I turned on the recording, I am going to record today's class because some of the material that we're going to talk about is stuff that for many of you is new, and you might not fully understand it the first time we go through it. So you might find it helpful if I post this recording on Canvas so that you can then go back and look at it a second time. Because quite often I've had students tell me that, yeah, being able to look at the recording really helped a lot. Okay, so what we're doing right now will be recorded, and then later this evening, I will post it on Canvas, and I encourage you to go back and look at it again. Okay, so the first thing that I intend to do today is talk about last night's homework. So when I look at your scores, I see room for improvement. Now, some of you did get 10s, but I see that those of you that got 10s, it took you a couple tries before you got it. Nobody got a 10 on your first try. One of you got a 10 on your second try, and then the rest of you that got 10s, it took you three tries before you got a 10. Now, some of you only made one try, and your score is really lousy. I mean, like maybe a 2 or a 3. Are you guys aware that if I set Canvas to give you multiple tries, you can do multiple tries? Now, sometimes I don't set Canvas for that, but in this case, I did have Canvas set. So when you submitted your first score, if you saw that your score was a low score, were you aware that you can go back and you can retake it? And in fact, I told Canvas to give you 3 tries. And some of you took 3 tries, but several of you didn't. In fact, a lot of you didn't even take 2 tries. You only took 1 try. So when I look at your scores right now, I'm seeing I'm seeing some 10s, and I'm seeing some like 5s and 6s, but I'm also seeing some 2s or 3s. So what that tells me is that there's some fundamental things that some of you don't understand. Now, don't feel bad, because I recognize that you're 9th graders and there are some things that maybe your math teacher hasn't got to yet. And so maybe there's a few things that we should spend a little time reviewing right now. Okay, so what I'm going to do for the next couple minutes is I'm going to go over the test, and I'm going to talk about how to do it. Now, I'm not going to go over every problem, because I want you guys to go back. In fact, what I'm going to do in just a minute is I'm going to reset Canvas so that you can then take as many tries as you need. But not for a minute. I want to leave it where it is right now. So let's go in and let's look at the thing on Canvas. So I'm sharing my Canvas page with you right now. And somebody just asked me, can you get full credit on a later try? I am going to say yes this time. Now, going forward, I'm not going to have that be my normal policy. But I realize that some of you are, just getting started. And so for this assignment, the answer is yes, I will let you get full credit as long as you go back in and redo it. Okay, so the assignment that was due today was this one right here, calculating how much energy your launcher needs to get a penny. All right, so let's go in and click on it. And now mine looks a little different than yours because I'm a teacher, but if I click on the preview button, then that'll make it so that mine looks a little bit more like what you guys see. Okay, so first thing that I trust that you noticed was that I tell you what is the equation for kinetic energy. Now, we talked about this last time, but just as a review, kinetic energy says if you've got some object with a mass m moving at some speed v, okay, it's going to have energy. It's going to have the ability where if this moving object were to hit a stationary object, it could push that stationary object. It could do work on that stationary object. The more mass it has, the more work it could do. The faster it's moving, the more work it can do. And when scientists experiment with this, they find out that if you double the velocity, it turns out that increases the amount of work you can do by a factor of 4. It doesn't double the amount of work you can do, it increases it by 4. If you triple the velocity, that increases the amount of work that you can do by a factor of 9. All right, so the equation for the energy of a moving object is 1/2 mv squared. All right, and so I gave you this, and I talked about the units for energy being joules if you are using the metric system. Okay, now some people don't like the metric system. Like, for instance, did any of you watch this video here? I'd like you to type in yes to the chat box if you watched the video, and type in no if you did not watch the video. Okay, so I see that you did. Okay. Was that not hilarious? I mean, Fox News astounds me with their arrogance and their stupidity. It was just, I cannot believe that anybody would be so stupid to say the things that they say on Fox News. So if your parents are Fox News watchers and they expect me to apologize for what I just said, I'm not going to apologize. Fox News deserves to be ridiculed. I mean, this example right here, this video here it's one of so many astoundingly stupid things that they say on Fox. But anyway, let's go on. So the metric system is actually not the communist system. It's not the yoke of tyranny. It's actually the system that makes sense. Okay, so question number 1 here. A lot of you got it wrong the first time. And it wasn't because you did the math wrong. It's because you didn't understand what I said right here. You didn't understand what I meant when I said that I wanted to see the answer using 2 significant figures, right? So that's what I want to talk about right now. Okay, so what does it mean to have 2 significant figures? Well, first off, let's do the problem here. So the problem says, okay, how much kinetic energy does the object have if it has a mass of 12 kilograms and is moving at a speed of 39 meters per second? Okay, so let's do what most of you did. Most of you said, okay, well, I recognize that kinetic energy is 1/2, oops, not 12, 1/2, sorry. Okay, try it again. So 1/2 mv squared. And so if the mass is 12 and the velocity is 39, so I'm going to put that in my calculator. So we get 1/2 times 12 times 39 squared. Don't forget to square the 39. Okay, so the answer I get on my calculator is 9,126. And so many of you entered that into Canvas, and Canvas said wrong. And so you went back and you said, well, maybe I just made a mistake. And so you went back and double checked, and no, 9126 is the right answer. Why is Canvas marking it wrong? Well, the reason Canvas is marking it wrong is because I specifically said, enter your answer using 2 significant figures. Now, apparently, that's new terminology that many of you did not understand. I assumed that your math teachers had talked to you about this, but apparently that's not the case. So don't feel bad. That's okay. We're going to talk about it right now. Okay, so I'm going to give you guys a little quiz. So I just opened up a whiteboard here. I'm going to give you a quiz. So everybody get out your calculators. And what I want you to do is answer this question right here. What is 6 times 3? Okay, and I want you to type your answer into the chat box using a private message, not a public message, because I don't want other people to see your answer. I want you to type in the answer, what is 6 times 3? Okay, I see that everybody, without exception, said 18. What if I were to tell you that that's not necessarily the right answer? Okay. Now, I purposely worded the question in order to trick you. If your math teacher asks you what is 6 times 3, then 18 is in fact the right answer. But if your engineering teacher asks you what is 6 times 3, Or if your physics teacher asks you what is 6 times 3, 18 might not actually be the right answer. And somebody just came to class here. Give me a sec to let them in here. Okay. So if your engineering teacher asks you what is 6 times 3, 18 might not be the right answer. Now, how is it possible that 18 could not be the right answer? Well, how about if I rephrase the question? Let's suppose that I have a rectangle and I want to know what is the area of that rectangle. Okay. And so then it's up to you to make the measurements in order to answer my question. So let's suppose you get out your ruler. Okay. And so this is your ruler right here. Okay. So this is 1 inch, 2 inches, 3 inches. And so and this is 0. So you hold your ruler up and you say, well, I think this side is 3 inches long. Now, is it exactly 3 inches long? Yeah, probably not. Okay. But 3 is the closest number there. So you're going to go ahead and you're going to call that a 3, but that is not exactly 3. It's a measured value that you measured to be 3. Okay, then what you're going to do next is you're going to get out your ruler and you're going to measure the length here. And let's suppose that you measure the length and you call it 6. But is it exactly 6? Well, probably not. Okay. So when you wrote the answer as 3, what you did was you rounded off what the answer really was. If you were to measure it more carefully, you might find that it's really 3.1297 blah 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 blah. Okay, but you just rounded it off to 3. Or it might have actually been 2.8317 whatever, but you just rounded it off to 3. Okay, so when you tell me that the answer was 3, what that really means is that the real, so let's say this is the length and let's say this is the width. So if you report the width as being 3, what that really means is that not the length. Hang on a second, let me fix that. The width. Okay. What that really means is that the width is something between 2.5 and 3.5. Okay. That's what it means when you report the answer as being 3 if it's a measured number. Same thing with 6. So if you report the length as being 6, well, that actually might have been as high as 6.5, or it might have actually been as low as 5.5. It's going to be somewhere in that range. Okay, so that's what it means when you write that. Okay, now the same thing over here. If you tell me that the area is 18, what that means is that you are confident that the real area is somewhere between 17.5. So hang on a sec while I fix this. Okay. 17.5 and 18.5. That's what it means. When you give me the answer like that, this is what it means. But is that really true? Okay. Look at the uncertainty. When you say that the length is 6, it might actually be as little as 5.5. And when you say that the width is 3, it might actually be as little as 2.5. So if I take 5.5 times 2.5, I get an answer of 13.75. So the area might, so even though I reported the length and the width as 6 times 3, the real, true, honest area might actually be as low as 13.75. Now, what is the biggest number that it might be? Well, if I want to know the biggest number, well, I just take the biggest number here times the biggest number there. So I get 6.5 times 3.5. So the answer there works out to be 22.75. Okay. Not 22.5, 22.75. Okay. So this is the real true range of what that area might possibly be. So if I report my answer as being 17, what that means is I am confident that the area is actually somewhere in this range. And you can see that's bogus. That's baloney. There's no way that I can know the area with that level of accuracy if my input numbers have this level of inaccuracy. This is the real true range. So this is why I must not report my answer as 18. Okay, does this make sense? So everybody please type into the chat box yes if this makes sense, or no if it does not make sense. Okay, good. I'm seeing lots of yeses. Okay, so in this class, 6 times 3 is not necessarily 18, because in this class, we're going to be working with measured numbers most of the time. Now, there will be a couple times when we do work with exact numbers, and hopefully it'll be clear, but we're going to assume that most of the time we're working with measured numbers. So what do we put in as the answer for what 6 times 3 is? Well, the best way to answer it is say 6.3 is some number that's somewhere between 13.75 and 22.75. That's the best way to answer it. But that's cumbersome. So here is the rule that engineers and scientists have agreed to use in a situation like this. What we're going to do is we're going to look at this number and we're going to say, how many significant figures are in this number? And in a minute, where I'm going to talk about significant figures, I'm hoping most of you know. So I only see one digit in that number, and I only see one digit in this number. So whatever I write my answer as, it had better also only have one digit. So if my calculator tells me the number is 18, that means, well, that's two digits, and I'm not allowed two digits. I'm only allowed one digit. So that means I need to either round it down to 10 or round it up to 20, whichever one is the closer one. And so hopefully, obviously, you recognize that rounding it up is the proper thing to do, not rounding it down. So what I need to do is I need to write my answer as 20, because this answer has what we call one significant figure, which is often called sig fig. Okay. So if my input numbers only have one sig fig each, that means my output number had only better have one sig fig. Okay. So in this class, 6 times 3 equals 20. Okay. And 12 times 4 equals 50. Okay. You're going to say, wait a minute, 12 times 4 is 48. Well, not in this class. In this class, 12 times 4 is 50. Now you might say, but wait a minute, Mr. Hendricks, I see two digits in that number, so shouldn't I be allowed to have two digits in my answer? I would say no, because this guy only has one digit. And so whichever number has the least number of digits, that determines how many digits I'm allowed. I call it digits, but I really should say significant figures. That's a better way to term, because 50, the zero technically is a digit, right? But it's not a significant figure. Okay. So what I need to do is if any one of my input numbers has one significant figure, that means my answer better only have one significant figure. So I better take the number that is in my calculator, and I either need to round it down to 40 or round it up to 50, whichever one is closer to. So in this case, obviously 50 is the one it's closer to, not 40. So you understand how that works? Okay, so let's do a little bit of practice. Let's suppose that I've got the number 4,951, and I want you to express that number with two significant figures. Okay, so I want you guys to write in the chat box using a private message, not a public message. How would you express that number using two significant figures? Okay, I'm seeing a couple answers. Okay. All right. interesting that what I'm seeing is interesting. I'm seeing all over the place. Okay, so some people are telling me that the answer is 4,900. Others of you are telling me that the answer is 5,000. And others of you are telling me that the answer is 5,100. And there's a couple of weird ones in there. Some of you are saying 5,050. Okay, so uh, so what we do is we take the number we've been given and we draw a dotted line after the second digit. And what we recognize is that these other guys, we got to turn them into zeros. Okay, so what we need to do is we either need to round this down to 4,900, or we need to round it up to the next number that has two zeros there. And the next number up is not 5,100. The next number up is 5,000. Okay, so which one is this guy closer to? Is he closer to 4,900 or is he closer to 5,000? Well, the answer is not 4,900. The answer is 5,000. Okay, now the reason this is a little bit tricky is that some of you are going to say, well, if you look at the number 5,000, I only see one digit there that's not zero. The rest of them are all zeros. So when I look at this number here, this number looks like it only has one sig fig, but actually that zero right there is significant. So this one is a little bit of a tricky one. That when I write the number 5,000, if I just write that on the board and I ask you how many significant figures it is, most of you are going to say, well, it looks to me like it only has one significant figure. You don't have any way of knowing that this zero is actually significant. And this is a bit of a problem. This is why scientific notation was invented. I don't want to go into too much detail about this, but if we were to write this in scientific notation, we would write 5.0 times 10 to the third. Is that, have you guys seen scientific notation? Please write in the chat box and tell me, have you learned about scientific notation in your math class? Okay, so I'm seeing a lot of yeses. Okay, that's good. If we write this number using scientific notation, then I know that everything that I see on the left side of the X there, those are all significant. Okay. So you can see why it does sometimes get a little bit tricky with scientific notation, with the sig figs. Let me give you one that's not so tricky. Let's suppose that I give you the number 83,921, and I want you to express that answer, but this time instead of 2 sig figs, I want 3 sig figs. Okay. So I want you to express that answer with using 3 significant figures. Type it in the chat box using a private message. Interesting. Okay. Okay, so what I'm seeing is that some of you are getting this, but some of you are not. Okay. I'm seeing one answer. Somebody said 84,000. Somebody else said 83,000. But hopefully you guys recognize that these guys right here, those guys have 2 significant figures. That's not what I asked for. I asked for 3 significant figures. So those aren't right. Okay, so some of you are saying 83,900, and others of you are saying, well, actually, this is what many of you are saying. And this one, okay, so there's one significant figure, there's the other significant figure, there's the third significant figure. So everything after that needs to be a zero. So what I do is I take this number that I've been given and I put a dotted line right here. And then I look at the next digit after that. If the next digit after the dotted line is less than 5, then I'm going to round down. If the next digit after that is greater than 5, then I'm going to round up. So 2 is clearly less than 5. So that means I'm going to round down. So yeah, this 83,900 is the right answer. Okay. All right. Okay, so hopefully you guys now understand a little bit more about significant figures. In this class, I am always going to worry about significant figures. And I'm going to set Canvas so that if you put in an answer that has too many significant figures, even though the number you put into Canvas is the number shown on your calculator, and you say, well, that's the right number. No, not necessarily. Okay? Because 6 times 3 is not necessarily equal to 18. If you're working with exact numbers, yes. But if you're working with measured numbers, 6 times 3 is not 18, not in this class, okay? Or even not in the real world. Okay, so be aware of that. Okay, so let's go back to the quiz here. So on question number 1, most of you that got question number 1 wrong, that was what you did wrong. So you did the calculations correctly, you just didn't give me the answer using the right number of sig figs. Okay, so I'm going to want you guys to go back and fix that. And in a few minutes, I'm going to change Canvas to allow you to redo it, but not right now. Okay, question number 2. Okay, this one, you had to use a little bit of algebra. Now, I realize you guys are just 9th graders, but this algebra is stuff that 9th graders can do. There is nothing in this problem that is beyond your capabilities. So what we do is we take the formula for kinetic energy, which was given up above. Okay, remember up above, it said kinetic energy is 1/2 times mass times velocity squared. So I'm telling you what the kinetic energy is, and I'm telling you what the mass is, and your job is to tell me what is the velocity. Okay, so what you need to do is you need to make your math teacher happy here. So the way that you're going to make your math teacher happy, so let me clear a little room here. And, okay, so you need to solve for V. You need to take everything that's not V and get it over on the other side of the equation. Okay, so what I'm going to do is I'm going to multiply the right side by 2. So the 2 and the 1/2 are going to cancel each other out. But the rules of mathematics say whatever I do the right side, I have to do the same thing left side. I have to multiply that by 2. Okay, now I got to get rid of the V. How is that V connected to the, or I'm sorry, I got to get rid of the M is what I got to do. How is that M connected to the V? Is that M plus V or is it N times V? Well, it's N times V, right? How do you undo multiplication? Answer, division. Okay, so I'm going to divide both sides by M. So that cancels that. Okay, so what I'm left with now is 2 times the kinetic energy divided by M equals V squared. How do I get rid of that squared? Jared, can you unmute yourself? What would I have to do to get rid of that squared?
You would divide.
Well, it's not V times 2. It's V
Well,
raised to the 2nd power. Okay, so Griff,
you would square root it.
square root it. Yay. Okay, that's what we want. Okay, so we're going to square root it. So let me switch to red here. So I'm going to square root that. And whatever I do the right side, I have to do the same thing left side. Those are the rules of math. Okay, so what that tells me then is that V is equal to the square root of 2 times whatever my kinetic energy was divided by M. And so now I'm finished with the algebra. And so now I do what I like to call plug and chug. And you've probably heard that term before. Teachers really like that term. All I have to do is just plug in the right numbers to the right place. So wherever I see an M, I'm going to replace it with 4.7. Wherever I see a kinetic energy, I'm going to replace that with 1500. Okay. So I get out my calculator. So I'm going to do the square root of 2 times 1500 divided by 4.7. So my calculator tells me that the answer is 25.26455,763. So do I put this into the box as my answer? No. Why not? Because the instructions say that I'm only allowed 2 significant figures. So I need to draw a dotted line after my second digit. And I am going to either round this down to 25 or round it up to 26. And whether I round down or up depends on what is the next digit after the dotted line. And I see that digit is a 2. So remember the rule, if it's anything less than 5, you round down. If it's anything more than 5, you round up. So this is less than 5, so we're going to round down. So the number that we're going to type into the box here is 25. Okay, if I type in anything more, if I type in more sig figs than 25, Canvas is going to mark it wrong because I told Canvas to do it. I told Canvas only accept answers that have 2 significant figures in it. Mark it wrong if it has more than 2 sig figs. Okay, is this making sense, sir? Give me a yes if this makes sense in the chat box. Give me a no if it doesn't. Okay, good. All right. So for many of you, this was something that you already understood. But when I look at what I see on Canvas, it's pretty clear to me that some of you needed this discussion. So hopefully you learned something important now. Okay, so let's look at the rest of them. Now, it's not my intention to do every single problem on the quiz. I just want to make sure that you guys are comfortable. So now that we understand about sig figs, hopefully we're not going to make that mistake anymore. All right, so question number 3, it says here that we've got a penny that has a mass of 25 grams, but a gram is not a standard physics unit. Okay, the standard physics unit, or the standard unit in the metric system, is the kilogram. So I need to convert from grams to kilograms. Okay, so you guys need to know how to do unit conversions. This is really, really important. We talked about this last time, and so I don't think that I need to talk about it again this time. So just put it in here, and so you should be good on that one. Okay. Next one here is, so let's suppose that somehow we know that the amount of energy that, or I'm sorry, we know that the speed that we need is 1.6 meters per second. Okay, so how much kinetic energy is that? Well, kinetic energy is 1/2 mv squared. So this is V, but what do we put in for M? What is the mass of a penny? Well, we just got through doing that in the previous problem, right? In the previous problem, we calculated what the mass of a penny was. Okay, so we should be able to get it from there. So question number 4, just recognize that in order to know the mass of the penny, we have to look back at question number 3 to get that. Okay, now, here is the thing where some of you ran into some trouble. Now, we talked about this last time, but apparently it didn't fully sink in for everybody. Okay. So if we want our penny to hit the target, okay, so if the target is 5 feet away and we're free to choose any height that we want, okay, so the velocity that we need to use is going to be different for some people than it is for other people. People who choose a low velocity, low height, they need a lot of velocity because otherwise their penny is going to hit the ground. So they need to shoot that penny out super fast if they want to hit the target. Other people who start off up higher, they don't need to shoot it so fast. Okay. So the velocity that we need to use in order to hit the target changes depending on what our starting height is. And this equation right here is the one that tells us what is the velocity we need depending on what is our starting height. But the catch is we have to work in meters. If we don't measure h in meters, this equation is not valid. Okay, so knowing that, so we come down into question number 5. Question number 5, it gives us the height in meters. So easy, right? All we have to do is just take this number here, plug it in for h, and whatever is v, that's our answer. Just make sure you use the right number of sig figs. So this one is really easy. There's no excuse for you guys not to get 100% on this one. Question number 6 is a little bit trickier, but not much. This time I told you the height, but it's not in meters, it's in inches. The equation up above doesn't work if h is not in meters. So what do we have to do? We have to take 14 inches and we have to convert that into meters. So unit conversions, okay? Now this one's a little bit tricky because first we have to convert it into feet. So we have to know that there's 12 inches equals 1 foot. Okay, so inches cancels inches, so we're left, but feet isn't right either. We don't want feet, we want meters. So then we have to say, okay, so there's 3.28 feet in 1 meter. Okay, so feet cancels feet. So the answer then is 14 divided by 12 and also divided by 3.28. That is the number that we put in for h. So this is the h, and this is the number that we put into that thing up above, not the 14. We have to put in this other number. Okay. So I hope you guys agree that the mathematics here is not really very complicated. This is stuff that a 9th grader can easily do. You just got to be careful. Okay, so the very last problems here. So if we come down to these very last ones here, it looks like the same thing. So it's telling you here's the height. But this time it's not asking for the velocity. This time it's asking for the kinetic energy, right? Many of you, what I could see what you had done. You had taken the formula from above that said velocity is 3.36 divided by the square root of h. Okay, so you took this number and you plugged it in for h, and you got a velocity. And what number did you get? Let's see, 3.36 divided by the square root of 0.55. Okay, so the answer that you got was 4.53 something. This was the number that you put in the box here. Oh, do you see the problem? This is the velocity. That's not what I asked for. I asked for kinetic energy. So what you got to do is you got to recognize that kinetic energy is 1/2 times the mass times the velocity squared. So this number that you got here, you got to stick that into this formula. And then you have to say, well, what is the mass of a penny? And hopefully you remember the mass of a penny, 0.0025. And I got that from above. So whatever this number is, that's what you need to stick in here, not the velocity, the kinetic energy, okay? So a whole lot of you made that mistake. So please don't make that mistake. All right, and then the very last one here is really the same as number 7. The only thing that I did differently here was I didn't give you the height in meters, I gave it to you in inches. So what you need to do is you need to convert that into meters and then use that to calculate what is the velocity, and then use that to calculate what is the kinetic energy, and then that's what you stick in the box. So that's a lot of steps. I mean, I realize you got to do one step here, and then you got to do another step here, and you got to do another step here, and you got to do another step here. So yeah, it's a little bit of a challenge, but you can do it. Every one of you should be able to do this and get 100% on it. Okay. So if I were to go into Canvas and reset Canvas so that it allows you to retake the quiz, how many of you think that you can get 100% on the retake? So type in I could if you think you get 100%, or if you still don't fully understand, type in, say, no, I still don't fully understand. Okay, one of you said, yeah, probably. There's no probably. I mean, you could do it. Okay, one of you said that you already did. Okay, good for you. All right. Okay, so I'm going to want you guys to do that. Now, here's the thing I need to wrestle with. I was planning to give you some new stuff to do today, but I'm worried that we don't have enough time to really do it right. What to do, what to do. Okay, how about this? I see that it's almost 10 minutes after 3. So how about if I do this? I'm going to give you guys the rest of the period to retake the quiz. And here's the deal. I want you guys to stay on Zoom. And I'm not going to let you go until Canvas tells me that you have a 10 on the quiz. So first off, let me go in and reset Canvas so it'll let you retake it. That'll take me about 10 seconds to do. Hang on a second here. Okay. Okay, good. Canvas will now let you retake the quiz, and Canvas will let you retake it as many times as you need. There's no limit. Okay, so what I want you guys to do is leave your cameras turned on. In fact, I'm going to turn off the recording in just a second, but before I do that, what I'm going to have you do is turn your cameras back on and retake the quiz and keep doing it until you get a 10. And then once I can see on my screen that you have a 10, then you can type in buy into the chat box and you can go. Now, one other thing, hang on a sec, don't turn your cameras just yet because we're still recording. So go turn it off for just a second. Okay, one other thing. Are you guys aware that next week, Monday, Tuesday, Wednesday, Principal Wilson has asked all of us teachers to attend a conference, so we can't be here live? Have you heard that from your other teachers? Well, if you haven't, then I'm telling you now. Okay, so what is today? Today is Wednesday. So that means the next time we're going to meet is going to be Tuesday of next week. Okay, so I will not be able to be here live to talk with you on Tuesday, but what I will do is I will post a video, and in the video, I will tell you guys what I want you to do. So if you just go onto Canvas, watch the video, and then just do the assignment that I tell you to do, I think you'll be fine. Okay, so you good with that? All right, so what I'm going to do now is I'm going to turn off the recording, and then you guys can get to work on retaking the quiz.